recording. Okay, I can do this. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture and name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Okay, so now we're going to go on and take a look at section 10.2. Part 1. Okay. Can everybody see the whiteboard now? Should be okay. Let me make sure. Yeah. All right. Now, in 10.2, we're going to look at something called the quadratic formula. I'm not going to go through all the details of how it was formed, other than to say what we just looked at, that square root property. There is a process that you go through called completing the square that sets up an equation in the form where you have a perfect square equals a constant on the other side of the equation. And you go through a lengthy process to do that. And what you can do is you can take an equation in the form, let's see here, of ax squared plus bx plus c equals 0. And by going through this whole process, you come up with a way to solve for x. And what you get is this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a, b, and c are the coefficients of those 3 terms when they're in descending powers. Okay? All right. Now, this is a very important formula that you should have memorized. So you're going to want to start working on memorizing that. And what I would do is each time you're doing a homework problem, try and do it from memory and then check it to make sure that, all right. So here we go. It says use the quadratic formula to solve each equation. And the equation is x squared plus 3x plus 2 equals 0. I want to point out that this is in that standard form, ax squared plus bx plus c equals 0. Therefore, a is 1, the implied coefficient of x squared. B is 3, the coefficient of x, and c equals 2. So now we're going to take this formula, whoops, hang on here. Let's see. And we're going to substitute a, b, and c into the formula. So it will look like this: x equals negative b, which is 3, plus or minus the square root of b, which is 3, squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. So again, I'm replacing a, b, and c with the coefficients from the second degree or quadratic equation I started with. So now it's a matter of massaging it, simplifying it down. So x equals negative 3 plus or minus the square root of 9 minus 8. 4 times 1 is 4 times 2 is 8, all over 2. X equals negative 3 plus or minus the square root of 9 minus 8 is 1, all over 2. X equals negative 3 plus or minus the square root of 1 is 1, all over 2. So x equals negative 3 plus 1 over 2, which is negative 2 over 2, or negative 1. X equals negative 3 minus 1 over 2, which is negative 4 over 2, or negative 2. So x equals negative 1, x equals negative 2 would be the 2 solutions to that equation. Let's check our work. Let's take this equation and plug both of those numbers in one at a time to verify that they both are true. X squared plus 3x plus 2 equals 0. And we said x was -1 and x was -2. If x is -1, I get -1, the quantity squared, plus 3 times -1 plus 2 equals 0. -1, the quantity squared is 1, plus 3 times -1 is -3, plus 2 equals 0. Let's see, 1 plus 2 is 3, minus 3 is 0, 0 equals 0, so it checks. Let's do the second one, -2. -2, the quantity squared, plus 3 times -2, plus 2 equals 0. -2, the quantity squared is 4. 4 plus -6 plus 2, 6 minus 6, 0 equals 0. So they both check. And I'm going to go back to this page in case anybody's still needing to write that down. Any questions about this problem? Okay, so let's continue to do examples of solving second-degree equations using the quadratic formula. Here we have x squared minus 18x plus 81 equals 0. This is in standard form. So we have a equals 1, b equals -18, and c equals 81. So there's that implied 1, -18 and 81. Lovely voice. All right. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice inside the radical that -18, that whole thing is all b, so it's all being squared. So now x equals negative times negative is positive 18 plus or minus, let's see, -18, the quantity squared, -18, the quantity squared is a positive 324 minus 4 times 1 is 4, and 4 times 81 is also 324, all over 2 times 1, or 2. X equals 18 plus or minus the square root of 0, 324 minus 324, all over 2. X equals 18 plus or minus, well, the square root of 0 is 0, all over 2. So I've got x equals 18 plus 0 over 2, and x equals 18 minus 0 over 2. So basically, I'm just going to get x equals 9, and both solutions would be x equals 9. So we might say this is a repeated solution of x equals 9. A second-degree equation always has two solutions. Sometimes they're unique, sometimes they're the same, sometimes they aren't even real numbers, but we won't worry about that at this point in time. Okay. All right. Any questions before we go on? Another example, 6x squared minus x minus 1 equals 0. Again, we have a quadratic equation, a second-degree equation. What makes it a second-degree equation? The fact that the highest exponent on the variable is a 2, right? Okay. This is in standard form, ax squared plus bx plus c. So a is 6, b is -1. There's an implied 1 in front of that x, so -1. And c is also -1. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The place that people make the most mistakes is inside the radical, messing up the sign. So be really careful with that. Okay, so x is the opposite of -1 is 1, plus or minus the square root of -1, the quantity squared is 1, Minus 4 times 6 is negative 24, times negative 1 would be a plus 24, all over 2 times 6, which is 12. Okay, so x equals 1 plus or minus the square root of 25 over 12. 1 plus 24 is 25. X equals 1 plus or minus the square root of 25 is 5 over 12. So x equals 1 plus 5 over 12, which is 6 over 12, which is 1/2. X equals 1 minus 5 over 12, which is negative 4 over 12, which is negative 1/3. So x equals 1/2 and x equals negative 1/3. Okay. Got my jug of water here, in case you're wondering what I'm doing over here. Okay. Now, let's take a look at this problem. 2x squared plus 7x equals negative 1. This is not in standard form. So what I'm going to do first of all is I'm going to add 1 to both sides of the equation so that now the equation is in standard form. Okay. For this problem, A is 2, B is 7, and C equals 1. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 7 plus or minus the square root of 49 plus 8. Negative 4 times 2 is negative. Oh, it's not plus 8, is it? No. Negative 4 times 2 would be negative 8 times 1 is, oh, it's negative 8 all over 4. X equals negative 7 plus or minus the square root of 41 all over 4. 41 is prime. It doesn't contain any perfect square factors other than just 1, which doesn't get us anywhere. So my solution is going to be, our solutions are negative 7 plus the square root of 41 all over 4, comma, negative 7 minus the square root of 41 all over 4. We'll say x equals, okay? Now, the instruction for this problem, it says solve each equation, approximate the solutions to the nearest hundredth. All right? So this has two parts. So here I have the exact solutions. Now what I'm going to do is I'm going to take these two answers and go to the next page so that I have lots of room to write. So we've got here, let's see, x equals negative 7 plus the square root of 41 all over 4, and x equals negative 7 minus the square root of 41 all over 4. We'll go back here for a minute if anybody's still working on that. All right. So now we're going to enter these into our calculators, and it said to round to the nearest hundredth. So we're going to go out to the second decimal place and then go to the third to either round up or down. But I have to be careful entering this into my calculator because I want to make sure that I divide the entire numerator by 4. So this is how I'm going to enter it into my calculator. I'm going to start with a left-hand parentheses. Okay. Then I'm going to put in negative 7 plus. Then I'm going to access the square root button, which on my calculator is a second function key. So I'll do that. And that'll give me this. I'll put in the 41. Then I'm going to close up that radical. And then I'm also going to close up the entire numerator. In fact, I'm going to go back and do this. I'm going to make this set of parentheses red just to emphasize that there are two different sets of parentheses there. This whole quantity is then divided by 4, and then I push the equal sign, okay? If you don't put in, let's see here, if you don't put in this set of parentheses, it's only going to divide the square root of 41 by 4. And it's the entire numerator that's divided by 4, okay? So you need to be careful with that. All right, so let's see what we end up with. Left-hand parentheses, -7 plus second square root of 41, close up the 41, close up the entire numerator divided by 4, and I get -0.149218941. But it said to round to the nearest hundredth, which would be right there. The 9 would round up, so my answer is going to be -0.15. Okay? Any questions about that half of the problem? So now we're going to go back and we're going to do the same thing, but using this instead. So it's going to be parentheses -7 minus the square root of 41, all divided by 4 equals, and let's see here. I get -3.350781059, but I'm supposed to round to the nearest hundredth, which is 2 decimal places to the right. The 0 would round down, so I'm going to get -3.35 as my other answer. So these are approximate answers to the nearest hundredth. Again, you've got to have both sets of parentheses. Any questions about that example? Okay, let's take a look at another problem. This says 3y squared equals 12y minus 4. This equation is not in standard form, so I need to get all of the terms on one side set equal to 0 on the other. Now, I could subtract 3y squared from both sides, and I'd have 0 equals everything else, and that would be okay, except then the 3y squared would be -3y squared on the right side. And again, that isn't wrong, but in the quadratic formula, you're dividing the whole thing by 2a. So it's easier if a is positive. So since this coefficient is the coefficient of the y squared term, that's going to end up being a. I'm going to leave that term on that side of the equation and move everything else over. So I'm going to subtract 12y, and I'm going to add 4 to both sides of the equation. So what that gives me is this, 3y squared minus 12y plus 4 equals 0. So now my equation is in standard form, and my leading coefficient, that is the 3, is positive, making it a little easier to deal with. Now, we said that the quadratic formula was x equals -b plus or minus the square root of 4b squared minus 4ac all over 2a. But it works not just for x, but for whatever variable you're solving for. So here, technically, y equals all of that, okay? So what do we got? We've got a is 3, b is -12, and c equals 4. So y equals -b plus or minus the square root of b squared minus 4ac all over 2a. There is a song that people use to memorize this. I'll sing it for you, though I probably should just keep my day job. It goes like this: -b plus or minus the square root plus or minus the square root of b squared minus 4ac, b squared minus 4ac all over 2a, all over 2a. I know. Keep my day job. It's hard to believe I have a music degree too. I know. But anyway, all right, going on. So simplifying this, y equals positive 12 plus or minus the square root of 144 minus, let's see, 4 times 3 is 12 times 4 is 48. It's kind of hard to read that that's a 4 right there. So let's make that a little bit easier to read. Okay. So 4 times 3 is 12 times 4 is 48. So minus 48 all over 2 times 3, which is 6. Okay. Y equals 12 plus or minus the square root of, let's see, 144 minus 48 would be 96 all over 6. We okay with that? So far, so good. Okay. Now, we could go straight from here to the decimal approximation it's asking for, okay? So if all they wanted was the decimal approximation, we could split this up and punch it into our calculators. But we're not going to do that. We're going to simplify our answer as much as we can first to get the most reduced, the most simplified exact answer. Okay, now, 96 underneath the radical, or inside the radical, contains a perfect square factor. So we can make this thing, we can simplify it. So let's see, 96, oh, what is that? Let's see, that would be 2 times 48, is that right? And 2 times 2 times 24, 2 times 2 times 2 times 12, 2 times 2 times 2 times 2 times 6, 2 times 2 times 2 times 2 times 2 times 6. I think that's right. Let's see. So that's 2 to the 5th power times 6, right? All right, so I want to take the square root of 2 to the 5th power times 6. Oh, wait a minute. Jump the gun here. In fact, let's go back one step further. I was getting worried because I was running out of room. 2 times 2 times 2 times 2 times 2 times 2 times 6, right? Or no, not times 6, times 3. So I've got what? 6 2s. See, is that right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 6. No, I don't think that's right. I see my mistake. Let's go back and do this better. I get worried when I feel like I have to hurry and I'm running out of room over on the edge there. Okay. Then we've got 2 times 2 times 2 times 2 times 2 times 3. So I've got 2 to the 4 times 6. Why didn't I make it 2 to the 5th? Because we're taking the square root, right? Okay. So the square root of 2 to the 4th would be 2 to the 2 power, which is 4. So all of that was to take this and turn it into that. Okay? That's what all that was about. So now I've got y equals 12 plus or minus 4 square roots of 6 all over 6. So I've simplified the radical as much as I can. But I can simplify the whole answer because I can reduce it down. Okay? And what I'm going to do, I'm going to take this and I'm going to put that on the next page. Y equals 12 plus or minus 4 square roots of 6 all over 6. Okay? So the box in red there, I'm going to the next page. Here's the thing. If these three numbers, this number, the coefficient out in front of the radical, and the denominator, if they all contain a common factor, we can reduce this thing down. They're all even. So let's rewrite this like this. Y equals 12 sixths plus or minus 4 square roots of 6 sixths. Why do that? Well, let's see. I can now reduce this down to what? 2, and this to 2 over 3. So y equals 2 plus or minus 2 square roots of 6 over 3. Okay, you see that? Now, there's another way to reduce this thing down, and I know this is getting like, really? It's harder to simplify the thing than it is to just get it in the first place. Another way that math people will do is they'll say, well, I want to keep it as a single fraction eventually. I could reduce this down to 2/3. Oh, I could make this 6/3. Why would I want to do that? Because then I could write y equals 6 plus or minus 2 square roots of 6 all over 3. Now, is either of those answers better than the other? No. And my guess is that WebAssign will accept both of them, okay? But what mathematicians tend to do is they like to have it as a single fraction, all right? But again, this answer is also correct, okay? I'm going to go with this one, and I'm going to go on to the next page. Y equals 6 plus or minus 2 square roots of 6 all over 3. And now we're going to go to the calculator. So we're going to say, first of all, y equals 6 plus 2 square roots of 6 all over 3. And then y equals 6 minus 2 square roots of 6 all over 3. So there's the two separate answers that you put in to say WebAssign. Okay. But now let's go to the calculator. So this is going to be parentheses 6 plus 2 square roots of 6, close it up. And then I'm also going to be closing up that little radical, right? Divided by 3. Okay. So parentheses 6 plus 2 times the square root of 6. Close up the radical, close up the entire numerator, divided by 3. And I get 3.6329936162. But again, it's saying to round to the nearest hundredth, which is right there. The 2 would round down. So I get 3.63. Okay. So there's the first answer. Okay. Then the second answer, we'd have what? 6 minus 2 square roots of 6 divided by 3. And so let's go up and do that. And we get 0.367006838. And I really only need to go here. The 7's going to round up, so 0.37. Any questions on that? All right. Now, there's some things that we can do if we have a second degree or quadratic equation and we want to use the quadratic formula to solve it. There's some things we can do to make A, B, and C nicer before we start plugging numbers in. So now, for instance, let's say we have the following: negative 5x squared plus 9x minus 2 equals 0. I mentioned earlier that it was easier to deal with if your leading coefficient is positive. So what I could do here is I could multiply both sides by -1. That would give me 5x squared minus 9x plus 2 equals 0. So now A is 5, B is -9, and C is 2. And then from there, I can plug that in to use the quadratic formula. Okay. Another example, let's say I have 1.6t squared plus 2.4t minus 0.9 equals 0. I could get rid of the decimals. Well, I'd need to move them over one place to get rid of all of them. So I'm going to multiply both sides of the equation by 10. This would give me 16t squared plus 24t minus 9 equals 0. So then A would be 16, B is 24, and C is negative 9. And you could go on from there and plug that into the quadratic formula. Okay. Another example, let's say we have a quadratic equation that contains fractions. How do you clear the fractions? Multiply both sides of the equation by the least common denominator. What's the least common denominator of 8, 2, and 4? It would be 8. So I'm going to multiply both sides of the equation by 8. So 8 times 1/8 x squared plus 8 times 1/2 x minus 8 times 3/4 equals 0 times 8. The 8's reduced down and I have x squared plus 8 over 4, 2 is 4 over 1, 4x. 8 over 4 is 2 over 1, minus 6 equals 0. So now A is 1, B is 4, and C is negative 6. Now, granted, you could use the original equation and plug those in for A, B, and C, but oh, it gets really messy, really ugly. You don't want to do that. You want to get rid of those fractions. So that's how you would do that. And then one other example, let's say I've got this 33y squared plus 99y minus 66 equals 0. Can you see that 33, 99, and 66 are all divisible by 33? So I could, in effect, divide both sides of the equation, that is each term, by 33. So now A is 1, B is 3, and C is negative 2, which you could then plug into the quadratic formula. Again, you could use the original numbers, but then you're going to get this huge, massive thing, and then you're going to have to simplify it, reduce it down anyway. All right. Okay, we are going to take a break. So this is to stop, this is section 10.2, part 1. Okay, so I'm going to stop the recording.